Hello everybody, today we're talking about 1.2a, which is displaying quantitative data with graphs. These are your learning objectives. You can pause and read through them more if you'd like. One of the basic ways that we can graph data is by using something called a dot plot. We map and scale out an axis and then label it with a name, of course. Those are easy points that you might miss. And then scale the axis from the minimum to the maximum and make a dot above each location that corresponds to that value. So as you can see here below, I've done all of that for the number of goals scored in a game. And then even though there's not a particular value, here you can infer that that's 5, for example. So it's a quick way to see a graph of the data. Data is very difficult to summarize by just looking at a list of numbers. So a graph helps us understand the data better in a very quick way. Some things that you can look at when you're trying to analyze the data in a graph is looking for an overall pattern, any departures from that pattern, and looking at things like the shape of it, where's the center, and how big or small is the spread. If you notice anything that really doesn't follow the overall pattern, we call this an outlier. You want to make note of that as well. And I will summarize this by saying don't forget your socks, right? Don't forget the shape, the outliers, the center, or the spread. So let's break down the socks a little bit more. When I say the shape, I'm talking about its symmetry or its skewness mainly. So if the graph is roughly symmetric, then you would call it symmetric. If the data is skewed right, then it has extra values on the right side. If it's skewed left, extra values on the left. This is a little bit backwards for some people, so some quick examples to illustrate what I mean. This first graph is symmetric, roughly, right? Almost nothing in stats is perfect. Symmetric. So if you imagine kind of a rough outline of this data, it looks a little bit like that. Maybe a dip here. But overall, this is roughly symmetric. Compare that to the next example. Skewed to the right would be the last graph. So I've got extra data on the right. In other words, if I covered this part up, right, if I took this extra part out, I would have a roughly symmetric graph. But by having a little bit extra on the right, it is what we call skewed right. The graph in the middle is a good example of skewed left for similar reasons. There is an extra tail on the left. There's extra data on the left. Other ways that you can describe shape, you can talk about where the modes are. Think of modes as peaks. So unimodal, there's one peak. Bimodal, 2 peaks. Multi, there's some other number. So that was all about shape. Now we're going to talk about outliers. Outliers are values that differ from the overall pattern. For now, we can just sort of estimate what an outlier is, right? What's a value that's obviously very far away from the rest of the data. So we would identify this, for example, as a potential outlier. Center, we're going to focus on 2 different ways to describe center. There are many, but in this class we're going to focus on 2 different ones, the median and the mean. Something to keep in mind is when you are describing center, think of that as a category. And you want to be more specific by specifying whether you're talking about the median or the mean, or sometimes both. So don't just say the center is blah, blah, blah. Specify the median is or the mean is. Now, something interesting happens when we've got different shapes of different distributions. So when we're talking about the shape as symmetric, roughly symmetric, that doesn't look roughly symmetric. So I've got something roughly symmetric. The median, and I'll use colors here, the median and the mean are roughly the same. But if I have a skewed distribution, so let's say I've got something right skewed, so there's extra data on the right. The median is not as affected. It might be a little bit to the right, but the mean will always follow the direction of the skew. It's heavily influenced by the skew. A dramatic example of this, think of your tests. You know, say you're averaging, 85, 90, 85, 90, and then all of a sudden you get a 0. That 0 tanks your test average because the mean is very easily influenced by outliers. So when we have a distribution that's skewed, it's best to talk about the median because that's not as easily changed. When we've got a roughly symmetric distribution, we want to talk about the mean because the mean as an average of all the values is a little bit more helpful in most of the cases. Spread, there's different ways to talk about spread, and we're going to get into this in more detail in future sections. But for now, you can think about roughly, something that has a higher spread is going to be fatter. Something that has a lower spread is going to be taller and skinnier. The most basic version of spread that you guys will be familiar with already is the range. You could specify, for example, in this distribution, values go from 1 to roughly 4.4. We'll get into what these other measures of spread are in a future section. So for comparing distributions, you always want to use shape, center, spread, and outliers if they're there. And use comparative language. So if I was looking at these two households, and actually, why don't you pause and look at these two household sizes and think of some ways to compare the two. All right, so for shape, I might say South Africa's distribution is skewed right for sure, whereas the UK's is roughly symmetric. Running out of space, so that means symmetric. Outliers. South Africa has let's say a couple potential outliers at 15 and 26. The UK has none. Sorry, Lily's very excited by stuff. The spread. Here's a good opportunity to use comparative language. So South Africa's Spread, let's talk about range specifically. Range is much higher. So I'm not just stating the two separately, I'm comparing them, which is what the question wants. And let's say this is about 26 minus 4, which is 22, while the UK's, that's terrible handwriting, I apologize. The UK's is 6 minus 2, we can estimate a little bit, 2 or 3, only 3. And shape outlier center, I haven't talked about center yet. Both, I think they have a similar center, center, and we'll get into how to measure this specifically later. I'll say a median value around 5. Another simple way to do a graph of quantitative data is a stem and leaf plot. This is similar to a dot plot, but it also shows the values, so you're not trying to guess, if you have a scale that isn't super clear, you just see the data itself rather than a dot. So here's a quick refresher on how to do a stem plot if you need. Biggest thing, don't forget a key. That's an easy point that you may get or you may miss out on. So let's look at a specific example in the next slide. This is a question asked of 20 female AP Stats students. How many pairs of shoes do you have? So I can construct a stem and leaf plot. Notice in my leaves, I only want one value. So I'm going to put the tens digit on the left for the stem. And then on the right, I know that this is 19, 13, 13, 13, 15, so on and so forth. So I'm showing you the different steps, how I would do it. So you want to make the stems first, then just add the leaves. Don't worry about order yet. You just need to get it on there. And then once it's all on there, you can order it from least to greatest. And then add a key. Sometimes when the data is all bunched up together, it's helpful to split the stems. So here's what I mean by that. Instead of just having one stem for 0, I've got 2. Instead of just having one stem for 1, I've got 2. This helps spread the data out a little bit. Also notice everything from 0 to 4 will go in the first stem, and everything 5 to 9 will go in the second stem. This helps the data stay consistent so you can still see the shape in a correct way. So if I was looking at the same question but for males, this would be what the split stem plot would look like. So here I've got 22, 35, 38, so on and so forth. Now a back-to-back stem plot is exactly what it sounds like. I've got the same stem, but I've got one group on one side, one group on the other side. This is a quick way to be able to compare two distributions using a stem plot. So for example, I can tell that males are skewed right. They have a lower center and a lower range than the females. The females are, I don't know, might even have 2 peaks, right? There might be a peak here and a peak here. And they've got a much larger range and a higher center. All right, here's your homework. Have a great day.